Hello and welcome back. In today's video, I'm overclocking the Ryzen Threadripper 7960X 24-core CPU all the way up to 5715 MHz using the GIGABYTE TRX50 Aero D motherboard and EK Quantum Custom Loop water cooling. Now, this is the second Ryzen Threadripper 7000 CPU that I've overclocked on this channel. I already tried the 64-core 7980X a while back. And even though the overclocking experience and strategies are very similar, there's still a couple of things that I learned as I was tuning this 7960X CPU. So today I'm sharing those things that I've learned, and I hope you also enjoy the video. The Ryzen Threadripper 7960X is the lowest spec processor of AMD's Zen 4 based Ryzen Threadripper 7000 high-end desktop series codenamed Stormpeak. The Stormpeak processors were announced on October 19, 2023 and entered the market as two distinct segments. The Ryzen Threadrippers and the TRX50 chipset are designed for high-end desktop. In contrast, the Ryzen Threadripper Pro and the WRX90 chipset are designed for workstation. There are a couple of differences between the Threadripper and the Threadripper Pro processors. The CCDs on the Ryzen Threadripper 7000 are the same as those on the Ryzen 7000 processors. There's just more of them. That means Zen 4 core architecture, 5nm TSMC, DDR5 and PCIe 5 support. The Ryzen Threadripper 7960X has 24 cores with 48 threads. The base frequency is 4.2 GHz and the listed maximum boost frequency is 5.3 GHz. The TDP is 350 watt and the TJ max is 95 degrees Celsius. In this video, we will cover 4 different overclocking strategies. However, before we jump into the overclocking, let's first have a look at the hardware and the benchmarks that we'll be using in this guide. The system we're overclocking today consists of the following hardware. The Easy Fan Controller SkatterBencher Edition, or EFC-SB, is a customized EFC resulting from a collaboration between SkatterBencher and Elmo Labs. By connecting the EFC-SB to the EVC2 device, I monitor the ambient temperature, water temperature, and fan duty cycle. I also use the Elmo Labs EFC-SB to map the radiator curve to the water temperature. We use Windows 11 and the following benchmark applications to measure performance and ensure system stability. Before we start overclocking, we must check the CPU performance at default settings. The default precision boost 2 parameters for the Ryzen Threadripper 7960X are as follows. I also want to take a couple of minutes to explain a very unique aspect of Ryzen Threadripper 7000 processors related to overclocking. Before you can start overclocking, even though all the Ryzen Threadripper CPUs are unlocked for overclocking, you must formally confirm that you enable the overclocking functions. And formally confirming means that it will leave an irreversible permanent mark on your CPU. The benefit of unlocking the overclocking capabilities is not just unlocking the overclocking tools, but also unlocking extra performance. The maximum CPU core frequency is limited to 5350 MHz by default, which is also the default specification on the AMD website. But after unlocking, the Fmax of CCD0 increases by 300 MHz to 5650 MHz. So how do you know if your CPU is unlocked for overclocking or not? Well, there's a couple of ways to do that. First, you can try setting an overclock in the BIOS to see if it works. If the overclock is not applied, then it's possible that overclocking has not been unlocked. Second, you can install Ryzen Master and try opening the software. If your processor is not unlocked for overclocking, the software will ask you to unlock it before showing you the settings. You can also check the BIOS on this GIGABYTE TRX50 Aero D motherboard. If processor OC mode is disabled under the System Info tab, your processor is locked for overclocking. For this guide, the performance figures I show as default settings are those after unlocking the processor for overclocking. So with a CCD0 Fmax of 5.65 GHz. Here's the benchmark performance at stock. Here are the 3DMark CPU profile scores at stock. When running the OCCT CPU AVX2 stability test, the The average CPU core effective clock is 4632 MHz with 1.152 volts. The average CPU temperature is 72.7 degrees Celsius. The average CPU package power is 349.5 watts. When running the OCCT CPU SSE stability test, the average CPU core effective clock is 4787 MHz with 1.225 volts. The average CPU temperature is 75.4 degrees Celsius. The average CPU package power is 346 watts. Of course, we can unlock the power limits by using Precision Boost Overdrive. And that's exactly what we'll do in our first overclocking strategy. However, before that, make sure to locate the Clear CMOS button. Pressing the Clear CMOS button will reset all your BIOS settings to default, which is helpful if you want to start your BIOS configuration from scratch. In our first overclocking strategy, we take advantage of enabling AMD Precision Boost Overdrive and enabling AMD EXPO. With the launch of Zen 3, AMD launched an improved version of their Precision Boost Overdrive Overclockers toolkit. They aptly named that Precision Boost Overdrive 2. Precision Boost Overdrive 2 builds on the PBO implementation of Zen 2. In addition to the overclocking knobs from Zen Plus, PPT, TDC and EDC, and Zen 2, Boost Override and Scaler, Precision Boost Overdrive 2 also introduced Curve Optimizer. There are essentially 3 levels of Precision Boost Overdrive. By enabling Precision Boost Overdrive, we rely on the motherboard pre-programmed PBO parameters. We find that the following values have changed. EXPO stands for Extended Profiles for Overclocking, and it's an AMD technology that allows for much easier memory overclocking on AMD platforms supporting DDR5 memory. EXPO allows memory vendors such as G.Skill to program higher performance settings onto the memory sticks. If the motherboard supports EXPO, you can enable higher performance with a single BIOS setting. AMD introduced EXPO with the launch of the Ryzen 7000 and its transition from DDR4 to DDR5 memory. Even though the Ryzen Threadripper 7000 is only compatible with RDIMM, it still supports the EXPO specification. Upon entering the BIOS, in Easy Mode, set XMP EXPO profile to EXPO 1. Switch to Advanced Mode. Enter the Advanced CPU Settings submenu. Enter the Precision Boost Overdrive submenu. Set Precision Boost Overdrive to Enabled. Then save and exit the BIOS. We reran the benchmarks and checked the performance increase compared to the default operation. As you'll see in a minute, this 24-core processor barely reaches the 350 watt TDP limit even in an all-core workload. Hence, we don't get any benefit from unlocking the power limits. However, enabling EXPO does provide a minor performance improvement in all-core workloads that are somewhat memory sensitive. The geo-mean performance improvement is plus 1.46%, and we get a maximum improvement of plus 7.88% in Y-Cruncher. When running the OCCT CPU AVX2 stability test, the average CPU core effective clock is 4784 MHz with 1.241 volts. The average CPU temperature is 75.8 degrees Celsius. The average CPU package power is 358 watts. When running the OCCT CPU SSE stability test, the average CPU core effective clock is 4786 MHz with 1.217 volts. The average CPU temperature is 72.5 degrees Celsius. The average CPU package power is 333.6 watts. The boost frequency at one active thread is about 5561 MHz and trails off to 5083 MHz when 7 cores are active. Then, when 8 cores are active, the C-state boost limiter kicks in and limits the frequency of all cores to 4.8 GHz. Despite cores 0 to 5 of CCD0 having a programmed if max of 5650 MHz, none of the cores achieve an effective clock higher than 5.5 GHz. For the other CCDs, only 3 cores achieve over 5.2 GHz, even though the programmed if max is 5350 MHz. In our second overclocking strategy, we use the GIGABYTE PBO Enhancement feature available in the GIGABYTE BIOS. PBO Enhancement, which used to be called Performance Bung, is a GIGABYTE technology that allows you to very easily tune the precision boost algorithm. It essentially gives you preset profiles which tune two settings: the maximum allowed temperature and an all-core curve optimizer. For example, this strategy's 90 level 1 profile will set the maximum temperature to 90 degrees Celsius and an all-core curve optimizer of -10. You can select your preferred profile based on the maximum temperature you're comfortable with and how well your CPU can undervolt. A lower maximum temperature will yield lower CPU frequency in all-core workloads. A higher negative curve optimizer will push the CPU frequency higher at a similar voltage. Note that PBO enhancement does not adjust the precision boost power limits, so you want to ensure that the PPT, TDC and EDC are also set correctly to maximize the performance. Upon entering the BIOS, in easy mode, set XMP EXPO profile to EXPO 1. Switch to advanced mode. Set precision boost overdrive enhancement to 90 level 1. Switch to the settings menu. Enter the AMD overclocking submenu. Click accept. Enter the precision boost overdrive submenu. Set precision boost overdrive to advanced. Set PBO limits to motherboard. Then save and exit the BIOS. We reran the benchmarks and checked the performance increase compared to the default operation. While PBO enhancement provides additional performance headroom with the minor curve optimizer improvement, it doesn't lift the maximum frequency. Hence, we don't expect significant performance uplifts. The geomean performance improvement is plus 2.03%, and we get a maximum improvement of plus 8.29% in Y-Cruncher. When running the OCCT CPU AVX2 stability test, the average CPU core effective clock is 4782 MHz with 1.242 volts. The average CPU temperature is 81.1 degrees Celsius. The average CPU package power is 350.3 watts. When running the OCCT CPU SSE stability test, the average CPU core effective clock is 4787 MHz with 1.186 volts. The average CPU temperature is 66.5 degrees Celsius. The average CPU package power is 309 watts. The boost behavior with increasing active threads is almost identical to the behavior we saw in the previous OC strategy. Also, the per core maximum effective clock is essentially the same. In our third overclocking strategy, we tried to use all of the available Precision Boost Overdrive 2 Toolkit overclocking tools to maximize the CPU performance. In addition, we're also going to fine-tune a little bit the Infinity Fabric, the system memory, and the memory controller frequency. Fused maximum frequency, or Fmax, is one of the precision boost infrastructure limiters constraining the performance of your CPU. Simply put, the Fmax defines the maximum allowed frequency for your CPU cores. Boost Clock Override, or Fmax Override, is one of the overclocker tools available in the PBO2 toolkit. It allows the user to override the arbitrary clock frequency limit between -1000 MHz and +200 MHz in steps of 25 MHz. We need to make three important notes about the Fmax Boost Clock Override tool. The override only adjusts the upper ceiling of the frequency and doesn't act as a frequency offset. Ultimately, the Precision Boost 2 algorithm still determines the actual operating frequency. Each CCD can have its own programmed Fmax limit. For example, on the Ryzen Threadripper 7960X, CCD0 has an Fmax of 5650 MHz, whereas CCD1 to CCD3 can only boost up to 5350 MHz. Lastly, Fmax Boost Override also lifts the C-state boost limiter frequency, which prevents the core from boosting to the Fmax when 8 or more cores are active. When we increase the Fmax boost limit by 200 MHz, the new Fmax of CCD0 is 5850 MHz, and the other CCDs have a new boost limit of 5550 MHz. Also, the new C-state boost limiter is 5000 MHz. Curve Optimizer is a very important new feature of the Precision Boost Overdrive 2 toolkit. Essentially, Curve Optimizer allows you to adjust the factory fused VFT or voltage frequency table of your CPU. In short, the VFT table defines what voltage is required for a given frequency and operating temperature. The higher your temperature or the higher your frequency, the more voltage is required. Curve Optimizer adjusts the VFT curve by offsetting the voltages of the factory-fused VFT curve. By setting a positive offset, you increase the voltage point. Conversely, you decrease the voltage point by setting a negative offset. The traditional AMD CPU overclocking method is to use negative curve optimizer. Two things happen when you use a negative curve optimizer setting. First, you tell the CPU that it needs less voltage for a given frequency, and as a consequence, at a given voltage, it can apply a higher frequency. Second, the CPU temperature will be lower because you use less voltage at a given frequency. That extra thermal headroom will also encourage the precision boost algorithm to target higher voltages and frequencies. On the Ryzen Threadripper 7000, Curve Optimizer is available per CPU, per CCD, or per core. The new feature, per CCD Curve Optimizer tuning, offers extra flexibility. However, mixing and matching with per core tuning is not possible. Just as with most AMD Ryzen processors, per core curve optimizing has a real benefit as it provides some cores with a lot more frequency headroom than others. People who follow me on X will have seen that I've tried to use the Ryzen Master Automatic Curve Optimizer function. It was the first time that I tried it, so I was curious to see what the outcome would be. Now, the process took quite a long time. I think the system was running for about half an afternoon or maybe even the entire afternoon, and the results were also a little bit odd. It recommended -48 for pretty much every core inside my CPU, and that wasn't stable. So I switched back to my manual curve optimization process. Once all that is done, I run through my usual benchmark suite and the stress tests, and if it all shows up with no instabilities, then I consider my curve optimizer settings as stable. The Infinity Fabric, sometimes called Scalable Data Fabric, is the primary means of communication between the chiplets on our CPU package. Basically, every chiplet on our package has a set of GMI links through which the CCDs will communicate with the IOD. The Infinity Fabric frequency and performance are most relevant for performance tuning regarding the memory subsystem performance. Since the DDR5 memory controllers are located on the I/O die, if the CPU cores need to store or retrieve data to and from the DDR5 memory, it has to go via the Infinity Fabric to the I/O die. The fabric frequency, or F-clock, is generated by the SoC PLL, derived from a 100 MHz reference clock input. The reference clock is multiplied by the F-clock ratio, which you can configure in the BIOS. The Infinity Fabric frequency is now decoupled from the system memory and CPU memory controller frequency, so you can set it independently. In my case, I further increased the fabric clock frequency to 2200 MHz, which is an increase of plus 200 MHz. If you want to play around with the voltages, you should know that the VDDG voltage supply provides the fabric voltage. 8 VDDG voltage rails are available for manual adjustment, 2 for each pair of CCD IOD connections. The DDR5 memory frequency, or M clock, is derived from the UMC clock, which is one of the SoC PLLs. The UMC clock is driven by a 100 MHz reference clock. The memory controller drives the system memory frequency, which we'll get to in a minute. While we still rely on the EXPO settings for memory timings and voltages, we also slightly raise the memory frequency from DDR5 6400 to DDR5 6600 for this OC strategy. The Unified Memory Controller Frequency, or U-clock, is also derived from the UMC clock, one of the SoC PLLs. The memory controller frequency is tied directly to the system memory frequency. It can either run at the same or half its frequency. Usually you would choose to run the memory controller and the system memory in sync, so have them operate at the same frequency, because that would provide you with the best performance. However, if your memory can overclock really high, so you get a really high system memory frequency, then sometimes running the memory controller at half the system memory frequency can still provide better performance. We run the memory controller frequency in sync with the system memory for this OC strategy. At DDR5 6600, the memory controller frequency is then 3300 MHz. Should you wish to adjust the memory controller voltage, look at the VDDP DDR internal voltage regulator. I want to quickly mention that I'm also using the GIGABYTE high bandwidth and low latency options in this OC strategy. Now, I've used these options before in previous SkatterBencher guides, and they always seem to help improve performance in memory sensitive workloads. However, GIGABYTE is pretty tight-lipped on what they do exactly. Enabling these settings may cause instability, so it's up to you to see if your memory is stable when they're enabled. In my case, I enabled the high bandwidth and low latency options and saw a positive performance impact in benchmarks like AIDA64 upon entering the BIOS. In easy mode, set XMP EXPO profile to EXPO 1. Enable XMP EXPO high bandwidth support. Enable low latency support. Switch to advanced mode. Set system memory multiplier to 66. Set Infinity Fabric frequency and dividers to 2200 MHz. Set uClock div 1 mode to uClock equals memclock. Switch to the settings menu. Enter the AMD overclocking submenu. Click accept. Enter the Precision Boost Overdrive submenu. Set Precision Boost Overdrive to advanced. Set PBO limits to motherboard. Set CPU boost clock override to enabled. Set max CPU boost clock override to 200. Enter the curve optimizer submenu. Set curve optimizer to per core. Set core 0 to 23, curve optimizer sign to negative. Set core 0 to 3 curve optimizer magnitude to 5. Set core 4 and 5 curve optimizer magnitude to 10. Set core 6 to 23 curve optimizer magnitude to 50. Then save and exit the BIOS. We reran the benchmarks and checked the performance increase compared to the default operation. As we try to squeeze the most performance out of the Precision Boost algorithm, we expect some performance bumps. However, unfortunately, there's not that much more headroom available. The geomean performance improvement is plus 5.20%, and we get a maximum improvement of plus 14.50% in Y-Cruncher. When running the OCCT CPU AVX2 stability test, the average CPU core effective clock is 4963 MHz with 1.296 volts. The average CPU temperature is 95.1 degrees Celsius. The average CPU package power is 375.1 watts. When running the OCCT CPU SSE stability test, the average CPU core effective clock is 4971 MHz with 1.323 volts. The average CPU temperature is 90.70 degrees Celsius. The average CPU package power is 353.9 watts. The boost frequency at one active thread is about 5532 MHz and trails off to 5450 MHz when 7 cores are active. Then, once again, the C-state boost limiter kicks in and locks all cores to a maximum of 5 GHz. We only see a slight improvement of the if max for cores in CCD0, where the curve optimizer setting is pretty low. That said, we have 3 cores that achieve over 5.5 GHz. The most impressive improvement, however, is with the cores in CCDs 1, 2, 3. With a maximal curve optimizer of minus 50, all cores boost over 5.5 GHz. In the fourth overclocking strategy, I will perform a manual overclock. And just like with the Ryzen Threadripper 7960X processor, which I overclocked on this channel previously, my stress test of choice is the OCCT CPU stress test with AVX2 enabled. Now, some people question the viability of a manual CPU overclock for Ryzen CPUs. And that's because once you switch to a manual overclock, you lose the benefit of the very high single-threaded boost frequencies of the Precision Boost algorithm. So whereas the Precision Boost algorithm can boost 1T up to 5650 MHz at stock, when you do a manual overclock, well, the maximum boost frequency will be limited to your highest set frequency. However, I believe there's a good use case for manual overclocking on Ryzen Threadripper, and that's for maximizing workload-specific performance. As I demonstrated in SkatterBencher number 43 with the Zen 3 Ryzen Threadripper, optimizing a specific workload can yield another 10 to 20% more performance than relying on a tuned precision boost algorithm. Furthermore, AMD introduced the C-state boost limiter on Ryzen processors, limiting the maximum frequency in an all-core workload. As we saw in OC strategy number 3, the CPU hits the maximum allowed frequency of 5 GHz in our OCCT stress test. This indicates there might be more headroom available in all-core workloads. Let's have a closer look at the CPU architecture to see where is the performance tuning opportunities embedded in this CPU. The frequency of the CPU cores is driven by a 100 MHz reference clock input. Each CCX has its own PLL and thus can run an independent frequency. The cores within a CCX share the same PLL, so they'll run at the same frequency. That means for the Ryzen Threadripper 7960X, we can set an independent frequency for each of the 4 CCXs. The voltage of the CPU cores is provided by not one but 2 VDD-CR CPU voltage rails. Counterintuitively, CCDs 0 and 3 are powered by the first power rail for this motherboard and CPU. The other 2 are powered by the second power rail. The voltage can be configured in 2 ways. Either you set the target VID by programming the CPU registers, or you directly set the target voltage of the voltage regulator. Only the latter is available in the main BIOS menus of this motherboard. Choosing the right manual voltage is always a matter of finding a perfect balance between increasing the overclocking headroom, ensuring that you can deal with the thermal challenges related to increasing the voltage, and of course consideration of the CPU lifespan. It's with that last thought that we kick off perhaps the most exciting or the most tedious part of Ryzen Threadripper overclocking, per CCX tuning. Our limiting factor will ultimately be the cooling solution, as power consumption increases exponentially with operating voltage and temperature scales somewhat linearly with power consumption. The maximum voltage will be determined by the application we are tuning for. So the first step in our tuning process would be to set a fixed CPU ratio and check the maximum operating temperature when running our workload. If there's thermal headroom left, increase the operating voltage. Once we know the maximum voltage, we can tune the CPU ratio of each CCX. Increase the CPU ratio of one CCX until the application shows signs of instability, then back off. Do this for each CCX sequentially, and you'll end up with the maximum stable per CCX frequency for a given voltage. In this table, you can find the maximum ratio for each CCX. As a reminder, the values in this table are for my specific system and a specific stability test. Your system may have wildly different values depending on the CPU sample, the cooling, the motherboard, and your chosen stability test. Upon entering the BIOS, in easy mode, set XMP EXPO profile to EXPO 1. Enable XMP EXPO high bandwidth support. Enable low latency support. Switch to advanced mode. Set CPU ratio mode to per CCX. Set CCD0 and CCD1 ratio to 52.50. Set CCD2 and CCD3 ratio to 52. Set system memory multiplier to 66. Set Infinity Fabric frequency and dividers to 2200 MHz. Set uClock div1 mode to uClock equals memclock. Set CPU vCore 0 to 1.2. Set CPU vCore 1 to 1.225. Then save and exit the BIOS. We rerun the benchmarks and check the performance increase compared to the default operation. With our manual overclock, we lose the benefit of the high precision boost single-threaded frequencies. We can see the effect clearly in the single-threaded benchmarks, where the performance is slightly lower than the stock settings. However, the benefit of the manual overclock is that our all-core frequency is much higher. The geo-mean performance improvement is plus 6.07%, and we get a maximum improvement of plus 22.34% in Y-Cruncher. When running the OCCT CPU AVX2 stability test, the average CPU core effective clock is 5218 MHz with 1.272 volts. The average CPU temperature is 88.6 degrees Celsius. The average CPU package power is 425 watts. When running the OCCT CPU SSE stability test, The average CPU core effective clock is 5218 MHz with 1.264 volts. The average CPU temperature is 81.8 degrees Celsius. The average CPU package power is 376.5 watts. As expected, the boost behavior and per core maximum effective clock is between 5250 and 5200 MHz. The most exciting thing about the manual overclock is that beyond 7 active cores or 14 active threads, the operating frequency is about 200 MHz higher than with a fully tuned precision boost overdrive configuration. Alright, let's wrap this up. When I started putting together this system, I was excited to try a GIGABYTE motherboard for a high-end desktop for the very first time. All the previous GIGABYTE motherboards that I've used were always for mainstream desktop. And even though I wasn't really that excited about the 7960X, actually I picked up quite a few things about Ryzen Threadripper 7000 overclocking by doing this overclocking guide. First, I think it's really cool that GIGABYTE added an option in their BIOS to double check whether or not your processor is unlocked for overclocking. While it shouldn't affect the warranty, so says AMD, I think some people will still prefer to purchase or to operate with a CPU that isn't unlocked for overclocking. Second, something that I only learned in this overclocking guide is that unlocking your Ryzen Threadripper 7000 processor also adds more frequency to CCD0. So when the processor is locked, CCD0 can only boost to 5.3 GHz, and when it's unlocked, it can boost to 5.6 GHz. Also, I had a closer look at the C-state boost limiter on this CPU. Now, I think in a CPU where you have maybe 64 cores, this C-state boost limiter maybe makes sense. But for this 24-core processor, it's very obvious that even when all the cores are under load, the CPU temperature isn't that high and the power consumption isn't that high. So I don't really think that AMD should employ a C-state boost limiter on this 24-core CPU. Maybe AMD says, we need to do this for longevity purposes. And in that case, I would suggest, add just an option to the Precision Boost Overdrive menu where the end user can decide whether or not to enforce this C-state boost limiter. Last point that I want to make about the 7960X is kind of tied with the previous point. Because there is this C-state boost limiter preventing the CPU to boost over 5 GHz in an all-core workload, there's actually a very good case to do manual overclocking for this CPU, right? As I went through the process of manual overclocking, I found out that my CPU could easily run 5.2 GHz in an all-core workload while also retaining lower temperatures. I think the temperature dropped about 6 to 10 degrees going from my highly tuned PBO to my manual overclock. That's great. More performance and lower temperatures. Anyway, that's it for this video. I hope you enjoyed it. I want to thank you for watching, and of course I want to thank the patrons for supporting my work. If you have any questions or comments, drop them in the comment section below. I'll also have a written version of this video up on my blog. And that's it. See you next time.